Video problem 83, the pH scale. Let's go ahead and take a look at this. Determine the pH of the following strong bases. So they are strong bases. The first one, we have 0.004 molar sodium hydroxide. So since it's a strong base, that sodium hydroxide breaks up completely and looks like this. Okay, now the reason why that's important is because since this is 0.004 molar, this hydroxide is 0.004 molar, and that's what we're concerned about. So we're going to be finding the pOH here since it's a base, and we're going to say that's equal to the negative log of the hydroxide, the concentration. So the pOH is equal to negative log of, in this case, 0.004. Alright, so type that into our handy dandy calculator. What that is? Negative log of 0.004, and we get a value of, for the pOH, 2.398. So to find the pH, it's pH plus pOH is equal to 14. So pH plus 2.398 is equal to 14. So pH is equal to 11.602. And remember, only these three digits here count as sig figs. So there's the pH for that one. Alright, here, letter B here. Now this one is gives off two hydroxides. So here's our calcium hydroxide, CaOH2. Now when that guy breaks up, it's going to break up into the one calcium, and then it's going to break up into the two hydroxides. So there are the two hydroxides. So if this is 1.25 times 10 to the negative fourth molar, this must be 2.5 times 10 to the negative fourth molar, because it's a 2-to-1 relationship. So when I calculate the pH, or pardon me, the pOH here, first I'm going to use that hydroxide concentration. So that's negative log of 2.5 times 10 to the negative fourth. Let me write the equation too. pOH is equal to negative log of hydroxide. Okay, so let's take the negative log of that value. And I get a pOH equal to 3.602. So I'm going to do the same thing with the pH and pOH, set them equal to 14 there, the sum of them. So pH plus 3.602 is equal to 14. So subtract 3.602 from both sides. And I get a value of, for my pH, 3.9, or 3.10, ooh, what am I doing? 10.398. And again, that's 3 sig figs. Looks like I should have 3 sig figs there. So there's my pH. And for the final one, we have 4 grams of potassium hydroxide. So let's take a look at this. Here's potassium hydroxide first of all. I've got 4 grams. I need the molarity. Right, it's 1 liter of total water. So I need to convert my 4 grams of potassium hydroxide to moles of potassium hydroxide. So I've got 1 mole on top, grams on bottom, moles over grams, grams over moles, talking about molar mass. In this case, molar mass of potassium hydroxide. So a potassium weighs 39.1 grams per mole, and oxygen weighs 16 grams per mole, and our hydrogen weighs 1.008 grams per mole. So when I add that all up, I get 56.108. Ooh, what am I doing there? 56.108 grams per mole. Right, so that's what goes there, 56.108. So I got 4 divided by that value, and I get, is that right? Yeah, 0.0713. And that's moles of potassium hydroxide. Now that's in 1 liter of water, so that's also the molarity. Alright, so again, I'm just going to use pOH is equal to the negative log concentration of the hydroxide. pOH is equal to negative log of 0.0713. and I get a value of, for my pOH, 1.147. So for the pH, again, I'm going to take the sum of pH plus pOH, set it equal to 14. I get a pH equal to 12 point, how many sig figs? Looks like I should only have 2 sig figs here, so 12.85 is going to be my pH. The 8 and the 5 are my sig figs. So there you go.